Okay, so this lesson is on inscribed angles. We're going to learn about what their properties are and how to apply them. Also, what an inscribed angle is. Okay, so an inscribed angle is an angle with its vertex. So remember the vertex, in this case, in this picture here, that would be B. The vertex is on the circle, and both sides are chords. So this is a chord. That means the endpoints are also on the circle. So pretty much every part of the angle, the ends lie on the circle. So that's an inscribed angle. Okay. Now, inscribed angles have some properties that we have to be aware of. The inscribed angle property says this: the measure of the inscribed angle is half the measure of its intercepted arc or central angle. So for example, let's say, I don't know, let's do, this is the arc, right? Okay, so let's say that arc is 100 degrees for simplicity's sake. Now, you already know that the central angle, this right here, would also be 100 degrees. Those are the same, right? Central angle, intercepted arc, same. Okay. So, but what this is saying is that this angle over here, this angle right here, is half of this arc right here, right? Arc AC. So half of 100, right? So if I go 100 divided by 2, I get 50. So that means that this angle right here is 50 degrees, okay? So the measure of the angle, the inscribed angle, is always half of the intercepted arc or the central angle, right? Okay, so that's what it says right here, but that's an important property. Okay, now there's a couple of things that come from this, directly from that, and they're called corollaries. So here is an angle. You'll notice that it intersects a diameter. So now if it intersects a diameter, you know that that means halfway across the circle, so that's 180 degrees. So that means that this angle right here would be half of that, right? 90 degrees. So whenever you have an intercepting diameter with an inscribed angle, it's always going to be 90 degrees because that's half of 180, and we know that a diameter is 180. So an inscribed angle intercepts a diameter. If that happens, remember this is the if-then statement. So if, and then we use that arrow for if, then this happens. So this is saying if an inscribed angle intercepts a diameter, then it is a right angle. So we're going to write that in there. Okay, so that's the first one. The second one is overlapping arcs. So in this particular one, they're looking at A, B, D, that angle right there. Now you'll notice that that intercepts this arc right here, arc AD. And so does this angle, inscribed angle right there. They open up to the same arc, arc AD. So that means that those two angles have to be the same. So that should make sense because they open up to the same arc. So then this means the measure of angle ACD is going to be the same. So if two inscribed angles intercept the same arc, the angles are congruent. Okay, so we're really going to use that property and then its couple of corollaries to answer some questions, and hopefully everything makes sense. So, okay, find each angle or arc measure. All right, well, here, this is the intercepted arc. That means this angle here is half of that. So that's 31 degrees. So the measure of arc WXY is 31, right? Easy peasy. Okay, now if you know the angle, then the arc is double that, right? So this arc right here, this major arc, it says the angle there is 113. So if I want to know what the arc is, it's going to be double that, 226 degrees. So it works both ways, right? Okay, PQR, right? That's that angle. You'll notice it opens up to this diameter again. So a diameter is 180 degrees on this side. So that means this has to be 90 degrees right here. Okay, just using one of those corollaries. Okay. It says here to find the measure of arc BC. So be careful here. We want to know what this is. Okay, so this arc right here, AC, is double 47, right? So that tells me that this is 94 degrees. Now I also notice that this passes through, that's a diameter, right? So that's half the circle. So the whole thing from here to here has to be 180. So if I go 180 minus 94, I get 86. And that's what's left over. That would give me the rest of this, right? Okay. All right, so this one, I want to know the measure of JKL, that angle. So that's this right here. But I don't know this arc. Okay, well, how can I figure this out? Well, I do know 53 and 65. So if I go 53, I don't know what happened there. Let's try that again. 53 plus 65 gives me 118 degrees. So from here to here is 118. So now all the way around we know is 360. So if I go 360 minus 118, that is 242 degrees. So this, from here to here, is 242. But I need to know this right here. So I'm going to have to, remember that's half of the arc. So half of 241, divide that by 2, I get 121 degrees. All right. Okay, so this one says find the measure of RST. RST is this one. And the measure of RUT. Okay, well, they both open up to the same arc. So if I could find that, they're going to be the same. So really, it looks like I have everything but this arc. So if I can find that arc first, so I want to add up 64 plus 139 plus 75. That'll give me, right, this all the way from here to here. Major arc RST. So that would be 278. I'll stay away from my calculator since it's been giving me so many problems. And then 360 minus 278. That's 82. Okay, so I know now, let's put that in there, that this is 82 degrees. So now both of these open up to that. So this should be 41 and this should be 41. They're both going to be the same because they open up to the same arc. Okay, so those are just using that property and its corollaries there. Hopefully that makes some sense. All right, now let's put a little bit of algebra in there, because that's what's going to happen a little bit. All right, so solve for x on these two problems. This first problem there's a couple different ways you could do it. The way that I'm going to do it is certainly not the only way you can do this. This is 67. I need to solve for x. I know that this, they're telling me that this arc LN is 4x plus 58. Now, I also can figure out what that is by doubling 67, right? If I go 67 times 2, right? That'll tell me what this is. So if I do that, that's 134. So really, I also know that this arc here is 134 degrees. So now I can just say, well, 4x plus 58 equals 134. There we go. Okay, so now subtract 58. We get 4x equals 76. And then divide that, you should get 19. I needed to just double check with my calculator for a second there, because for whatever reason that was struggling in my head. All right, so we get x equals 19, and that we only need to solve for x, so there we go. All right, so hopefully that makes some sense. Another thing you could have done is gone like 67 equals 1/2 4x plus 58, right? Because it's half the arc, and then solve for that. You would get the same answer. Okay, next one. So this one we're solving for x as well, but it looks like we're going to have a little extra to maybe do on this problem. So first, I know this angle is 114, so that opens up to this arc, so that's going to be double. So I'm going to write that's 228. Okay, so then if I subtract what I have left, that'll tell me this amount. I have 78 plus 228. So if I take that away from 360, so if I go 78 plus 228 is 306. So that's right, that distance around. So now take that away from 360, I get 54. So this is 54 degrees. Okay, so now that means in here, this is half of that, 27 degrees. So now I can say 7x plus 6 equals 27, and just solve. Okay, so x is 3. There we go. Hopefully that's making some sense for you. All right. Okay, there's one other thing that I want to go over in this lesson, and that's about, so you have inscribed angles that end up forming a shape, and in this case a quadrilateral, a four-sided shape. So a quadrilateral, if a quadrilateral is inscribed in a circle like you see here in the picture on the left, then its opposite angles are supplementary. Now, this is a fairly simple proof to do, but I won't do that just in the interest of time on this video. But the opposite angles are going to be supplementary. Remember, that just means adds up to 180 degrees. Okay, so in our picture, the measure of angle A and C, those two right there, I should not do arcs. Those two angles are going to be, they're opposite of each other, so they should add up to 180. And then the same thing with this angle, B and D. Those two, if I add those up, I will also get 180 degrees. So any opposite angles, right, this one and this one, should add up to 180. So we're going to use that property to just help us out. Okay, so this first one says, find each angle or arc measure. Okay, so I know that Q is right here. Its opposite angle should add up to 180. So if I go 180, I suppose I should use my other pen. 180 minus 93, I get 87. So this is 87 degrees. Well, we got that one already. Okay. Now R opens up, that angle opens up from here to here. Okay, well, I don't know what R is, but I do know that its intercepted arc would be 126 plus 90, which is 216. Okay, so now if I cut that in half, divided by 2, that would give me 108. So that means this is 108. So that's R, 108 degrees. Okay, so then if its opposite angle, P, plus R, they should add up to 180, then I can say, well, 180 minus 108 is 72. So this should be 72 degrees. And we got them. And that's just using that property there. So I hope that makes some sense. All right, let's try one more. Okay, it says solve for X. Okay. Well, this angle right here opens up to this inscribed arc, right? So maybe if I suppose make this opens up to here. Okay, so if I go 135 plus 91, that would be 226 degrees. Okay, so this is 226, that pink arc. So that means angle N would be half of that, sorry, should be 113. Okay, so now how are we going to do this? Well, I know that this angle N and this angle L, if I add them together, I should get 180. So that's what I'm going to write. I'm going to say, all right, 15x minus 23 plus 113, which is angle N, so L plus N, that should equal 180. Okay, so now if I combine like terms, 15x plus 90 equals 180. Subtract 90 from both sides. We get 15x equals 90. Divide by 15. And that would be 6. And we did it. So this is inscribed angles, properties, corollaries, and then just a little bit about how inscribed quadrilaterals work. I hope that makes sense. You can go ahead and try this assignment. Don't forget to write things into your planner.